Hello everyone, and welcome back to the channel, where we take math problems that look a little bit intimidating and break them down into pieces that are easy to digest and actually kind of fun to solve. So today we have a really interesting system of equations that I want to share with you, and it is a classic setup where we are given the sum of two numbers and the product of those same two numbers, and we have to figure out exactly what those numbers are. So specifically, we are looking at the first equation, which is x plus y equals 20, and the second equation, which is x times y equals 44. Now, before we even pick up a pen or start writing anything down, let's just use our intuition for a second. Because normally, when you see a problem like this, you might try to guess the numbers, right? You might think, okay, what two numbers add up to 20? Well, 10 plus 10 is 20, but if you multiply 10 times 10, you get 100, which is way too big compared to 44. Or maybe you try 2 and 18, which adds to 20, but 2 times 18 is only 36, which is too small. So that tells us right away that the answers we are looking for are probably not going to be nice, clean, whole numbers. They're likely going to involve some decimals, or in our case today, some square roots, which makes this the perfect candidate for using algebra, specifically the substitution method combined with the quadratic formula. So grab your paper and let's dive into step number 1, which is all about isolating a variable. We need to take that first equation, x plus y equals 20, and we need to rewrite it so that one variable is all by itself on one side of the equal sign. It honestly does not matter if you choose x or y because the equations are symmetrical, but let's just stick with custom and solve for y. So if we want y by itself, we need to move that x over to the other side, and we do that by subtracting x from both sides.
Express y, which is y equals 20 minus x, and this is going to be our golden ticket for the next step, because now we can move on to step 2, which involves substitution. We are going to take that second equation, the one that says x times y equals 44, and we are going to perform a swap. Instead of writing the letter y, we are going to replace it with the expression we just found, which is 20 minus x. So now the equation looks like x multiplied by the quantity 20 minus x equals 44. And this is a huge moment because we have successfully gone from having two different variables, which is hard to solve, to having just one variable x, which is something we can definitely handle. So now we need to expand those brackets. We distribute the x into the parentheses. So x times 20 gives us 20x, and x times negative x gives us negative x squared, and all of that is still equal to 44. So our equation is now 20x minus x squared equals 44. But we are not done yet, because this is looking like a quadratic equation. And to solve a quadratic equation properly, we generally want to set the whole thing equal to 0. So let's move that 44 over to the left side by subtracting 44 from both sides, which gives us negative x squared plus 20x minus 44 equals 0. Now, I don't know about you, but I really do not like having a negative sign in front of my x squared term. It just makes things messy and increases the chance of making a silly sign error later on. So a great pro tip here is to multiply the entire equation by -1 just to flip all the signs. So negative x squared becomes positive x squared, positive 20x becomes negative 20x, and negative 44 becomes positive 44. So now we have a beautiful, clean, standard quadratic equation, which is x squared minus 20x plus 44 equals 0. And this is the point where we realize we can't easily factor this in our heads like we talked about earlier. So we are going to bring in the heavy artillery, which is step 4, using the quadratic formula. If you don't have this memorized yet, it is x equals negative b plus or minus the square root of b squared.
Minus 4ac, all divided by 2a. So let's identify our players here. Our a value is simply 1 since there is just a single x squared. Our b value is negative 20. Don't forget that negative sign, that is crucial. And our c value is positive 44. So now we carefully plug these numbers into the formula. So x equals negative 20, which just becomes positive 20, plus or minus the square root of negative 20 squared minus 4 times 1 times 44, all divided by 2 times 1. Now we need to simplify what is happening inside that square root symbol. First off, negative 20 squared is negative 20 times negative 20, which gives us a positive 400. And then we have 4 times 1 times 44. Well, 4 times 40 is 160, and 4 times 4 is 16. So adding those together gives us 176. So now inside the square root, we have 400 minus 176, and the whole thing is divided by 2. Let's do that subtraction. 400 minus 176 leaves us with 224. So our current status is x equals 20 plus or minus the square root of 224 all over 2. And this brings us to step 5, which is simplifying that radical. Because the square root of 224 is not a perfect square, so we need to break it down. We're looking for the largest perfect square that hides inside 224. You might have to do a little bit of trial and error here, but if you test dividing by 4, or 9, or 16, you will eventually find that 16 goes into 224 perfectly. Specifically, 16 times 14 equals 224. And this is great news because 16 is a perfect square. So we can rewrite the square root of 224 as the square root of 16 times 14. And since the square root of 16 is just 4, we can pull that 4 outside of the radical, leaving the 14 trapped inside. So now we have x equals 20 plus or minus 4 times the square root of 14, all divided by 2. And notice that every single number in this fraction is an even number. 20 is even, 4 is even, and 2 is even, which means we can simplify this fraction by dividing everything by 2. So 20 divided by 2 is 10, and 4 times root 14 divided by 2 is 2 times root 14. So we have our two possible values for x, which are 10 plus 2 times the square root of 14, and 10 minus 2 times the square root of 14. But wait, we are not finished yet, because remember, we are looking for a pair of numbers, x and y, so we need to find the matching y values for step 6. Luckily, we have that super simple equation from the very beginning where y equals 20 minus x. So let's take our first x value, where x is 10 plus 2 root 14. If we plug that in, y will be 20 minus that whole chunk. So 20 minus 10 is 10, and we have to distribute the negative, so it becomes minus 2 root 14. So when x is 10 plus 2 root 14, y is 10 minus 2 root 14. And interestingly, if we use the other value for x, where x is 10 minus 2 root 14, and we plug that in, y becomes 20 minus 10, which is 10, but the minus negative becomes a plus, so y becomes 10 plus 2 root 14. Essentially, x and y just trade places, which makes total sense, because x plus y and x times y are symmetrical operations. So, there you have it, folks. The two numbers that sum to 20 and multiply to 44 are 10 plus 2 root 14 and 10 minus 2 root 14. Thanks for watching, and keep practicing those quadratics because you are doing great.